All right, let's start our conversation about like terms with two simple questions. First, I'd like you to tell me what 3 means, and then I'd like you to tell me what 2x means. We usually think about 3 meaning that you have a 1, and then a 1, and then another 1. Whereas 2x means you have this unknown amount, x, or this amount that can change, but you don't just have one of them, you have 2 of them. So what would you have if you had 3 and then you added 2x to that? Well, you would have 3 1s and then you would have 2 x's. Could we combine those ideas at all? Could we say that we have 5 1s? Well, that wouldn't make sense because we only have 3 1s. There's no place for those 2 other 1s to come from. Could we say that we had 2 x's? Well, I'm sorry, could we say that we have 5 x's? That wouldn't make sense either because we only have 2 x's. The other 3 things aren't x's, they're 1s. So really what we have is we have 3 1s and 2 x's. We couldn't simplify that at all. Although I will tell you we would prefer to write it as 2x plus 3. When we have 2 different kinds of terms, we like to have the variable term in front. Okay, so let me ask you this question. What if we had 3 1s and we add to that 2 x's, and then we add to that 5 more 1s, and then we add to that 4 x's? Well, let's see. We would have those 3 1s and those 2 x's and those 5 1s and those, what do we have here, 4 x's. If we look at what we have here, it's kind of disorganized, right? We have 1s in multiple places and we have x's in multiple places. What if we were to reorganize that so we had all of our 1s in one place? So here's a 3 1s and here's 5 1s. And then we had all of our x's in another place. So here's plus 2 x's and here's plus 4 more x's. Now we can pretty clearly see that the number of 1s we have total is 8. The number of x's we have total is 6, so we have 6 x's. Although again, we would prefer to write this with the x term first as 6x plus 8 1s. Right? So let's talk a little bit more about what we have here. This value 3 is an example of what we call a constant term. And that word constant essentially means it doesn't vary, it doesn't change, it's not variable. Constant is effectively the opposite of variable. Speaking of variable, the other term we were talking about here, the 2x, that's an example of a variable term. A variable term, simply put, is a term with a variable in it. So when we look at our variable term here, which is 2x, notice that it actually has 2 pieces, right? It has the variable, which in this case is x, but it also has this number out in front of the variable. It tells us how many of that thing we have. The name of that number in front, we call that term the coefficient. And in this case, because it's the variable term has an x in it, we call it the coefficient of x. If the variable were a different letter, it would be the coefficient of that letter. All right, then let's talk about combining our like terms. First, let's talk about what that means. What does the word like mean in combining like terms? It doesn't mean that someone has a crush on someone in this case. What it actually means, the word like in this case, essentially means same kind. So when we talk about combining like terms, really what we're saying is we want to combine the terms that are the same kind of term. So when you have an expression, like what we had up here, where we have 2 or more of the same kind of term, you should, now we're going to have 2 steps here, but I want to clarify what this means. Here we have an expression, 3 plus 2x plus 5 plus 4x, and we have 2 constant terms, so we have 2 of the same kind of term in terms of constant terms. We also have 2x and 4x, so we have 2 of those variable terms. Here's what we should do. we should first focus on reorganizing. So we should reorganize the expression, so that the like terms are next to each other, right? And you can actually see that we did that up here, right? Here we reorganize this, we change the order of the terms that we had so that the 3 and the 5, which were both constant terms, are next to each other now. And the 2x and the 4x, which were both variable terms in x, are both next to each other, right? After we reorganize that, we should combine the like terms. And the idea behind that is just, look, you could say that you have 3 1s and 5 1s, but it's a lot easier to just say that you have 8 1s. The last thing I want to say is that, for this little section, is that when we talk about the terms, right, just to clarify what that word terms means, it's the pieces of an expression that are separated by addition or subtraction. So 2 and x are not separate terms here. 2x is one term, 3 is another term, 5 is another term, 4x is another term. This expression starts out with 4 terms and ends with 2 terms. All right, we're going to watch the next video now to see the examples and the your turn problems.